Name of subject, internal combustion engines. Name of chapter, SI engines fuel supply system, ignition system, combustion. Name of topic, transistorized coil assisted ignition system. Contents, transistorized coil assisted ignition system. So, dear friends, in the last few videos, we already discussed about the different types of ignition system, like the electronic ignition system, then that capacitive discharge kind of ignition system itself. But such kind of ignition system has some limitations, has some disadvantages. So to overcome that limitation, to overcome that particular disadvantages, we have to use another kind of ignition system, and that is nothing but called the transistorized coil assisted ignition system. So what is this? So with the help of this diagram we can understand this particular technological assisted ignition system, that is nothing but the transistorized coil assisted ignition system. So before going to understand the working principle of this particular system, we must have to understand few things. The main principle of transistorized ignition system is to use transistors as electronic switches instead of breaker points. So if you remember in the earlier videos, in the earlier type of ignition system which we discussed in the earlier videos, in that case we have used the breaker points. But in the case of this particular transistorized coil assisted ignition system, that particular breaker points are basically replaced in some cases. So it is replaced by the electronic switches, and that is nothing but called the transistors. So instead of breaker points, here we are using the transistors as electronic switches. So in addition, when the breaker point is stretched, the frequent sparking occurs at the breaker point so that the induction power of the ignition coil is reduced. So this is the major disadvantage of the use of breaker, and because of the very much high amount of heat generation inside the circuit, there will be a chances of failure of the breaker circuits or the breaker points. So to avoid that things, and because of that particular thing, sometime the ignition coil capacities also get reduced. So to avoid all these things, we are using this new concept or these new things, that is nothing but called as the transistors in the ignition mechanism. Okay, and the transistor is nothing but called as the electronic kind of a switches. So this particular system consisting what? So we start with the battery, then there will be a requirement of ignition switch, again the ignition coil which has the primary and secondary winding, then the resistor, then the emitter, then there is one base, and there is one capacitor. So these all things together is nothing but called as a transistor. So what it consisting? Capacitor is nothing but called as a collector also. So here is one base and here is one emitter. So these three parts combined together forms a transistor. So this base, which is again connected with the help of one resistor to a one contact breaker to complete this particular circuit, and there is one rotary cam is again present. So the another end of this particular ignition coil or the winding which is connected to the distributor system, where the number of spark plugs are connected. So 1, 2, 3, 4. Suppose 4-cylinder engine is there. That time we have to use the 4 spark plug which is present inside the engine cylinder. Okay. So these are the 4 spark plug which is connected to the distributor system. So when we talk about the construction, so here is the particular battery, the negative end of the battery which is connected to the ignition switch, and via ignition switch it is connected to the primary winding in the ignition coil. So the another end of the battery, that is a positive terminal which is connected to this particular capacitor or collector, and then through it is connected to the base plate and then emitter, resistor, etc. So here is one circuit we can say. So the another end of the secondary winding which is connected to the distributor system, where the distributor rotor is present and number of spark plugs are connected to the distributor. Okay, so this is something about this particular circuit of transistorized coil assisted ignition system. So how it will work? So this is again very important question. So initially, when there is some connection in between the ignition switch, and that time the current will flow from the battery through this particular ignition switch to the primary winding, like this, and through the resistor it will come in the emitter, and through the emitter the current will pass through the base system itself. So everywhere there is a flow of the current, means from the battery to the capacitor system, then to the base, emitter, resistor. So this completes the circuits, and continuously there is a flow of the current in the form of some amount of voltage. Okay, but what happened as there will be some contact. In this case, initially there is a contact. Right now there is a contact breaker is there, and here in this particular situation, or in this diagram, there is a break in the contact. Okay, but initially there is a continuous line, or the continuous circuit is there. If the circuit is continuous, that time the flow of current from battery, ignition switch, the primary winding, resistor, emitter, transistor, or the capacitor, and this particular base circuit, means this continuous circuit is there, and the amount of current will flow through this one. Okay, but what happen as there will be a break in the contact? We can say if there will be a contact break, that time what happened, the flow of the amount of voltage, or we can say that particular electricity supply, or the current which flowing from this particular circuit will start to will start to stop to flow from this particular circuit. Okay, please concentrate on my statement. When there will be some break in the contact, that time what happen? There will be a stop in the flowing of the current through this particular circuit over here, and instead of that, whatever current which is excited in the primary winding, the field will be generated, and because of that particular field, the secondary winding which is present over here, it will get excited, and huge voltage will be generated, and that huge voltage will supply to the distributor system, and from the distributor it will supply to each and every spark plug. So this is the simple working of transistorized coil assisted ignition system. So how there will be a contact break? So this contact breaker is totally working on the rotation of this particular cam. So as per the requirement of the spark plug, this particular cam will rotate, and it will break the contact. Unless and until there will be a breaking in the contact, the excitation will not flow from this particular primary winding to secondary winding. So this contact breaker is again or important in this particular case. So we have neglected the contact breaker direct use, where there will be a chances of the generation of heat. So instead of that, in this case, we have using the transistor system. Okay, so as we initially discussed the things about the contact breaker. Okay, so to understand this particular concept thoroughly, we will watch one video, and with the help of that particular video, whatever doubts in your mind, it will be get clear. So please watch the video.
Hey guys, welcome back to the channel. Components and systems are being continuously replaced by electronic systems over the years, right? Well, ignition system is not an exception to this. In this video, we will discuss one of such electronic ignition systems called the transistorized ignition system. Today, we will be discussing the need, construction, working, advantages, and disadvantages of the transistorized ignition system. In our previous videos, we learned about battery coil and the magneto ignition systems, but these systems have their very own disadvantage. Do you guys remember what it is? Well, it's the contact breaker. If the current produced in the primary circuit is too high, it may cause the breaker points to burn. Thus, the current in the system should be limited to avoid this. On the other hand, when the engine speed is high, the breaker opens too quickly, which allows lesser time to develop the magnetic field, and results in low spark voltage. These problems can be overcome by using transistorized ignition system. It's an electronic ignition system which uses a transistor as a switch for assisting the work of the contact breaker. Hence, it is also known as transistor-assisted ignition system. Before moving on to the construction of the transistorized ignition system, let us see the significance of transistor as a switch. A transistor consists of three terminals, namely the base, emitter, and the collector. The collector and the emitter acts as the input and output terminals, whereas the base acts as the controller. In brief, the current flow between the collector and emitter is possible only when there is a current flow in the base. If the current flowing through the base stops, the current flowing between the collector and the emitter stops as well. This transistor property of acting as a switch makes it prominent in the ignition system. Now, let us move on to see the construction of the transistorized ignition system. It consists of a battery, an ignition switch, an ignition coil, a transistor, a contact breaker, a distributor, and the spark plugs. The negative terminal of the battery is connected to one end of the primary coil, and the positive terminal is connected to the ignition switch. The other end of the primary coil is connected with the emitter of the transistor, whereas the collector is connected with the ignition switch. The base of the transistor is connected to the contact breaker. On the other hand, one end of the secondary coil is connected to the primary coil and the other end is connected to the distributor. The distributor is then connected with the spark plugs. Now, how does this system work? When the ignition switch is on and the contact breaker is closed, the current flows from the battery to the primary coil. As the contact breaker is connected with the base, it draws only a low current, whereas a high current is passed through the collector. The current flowing through the primary coil develops a magnetic field around it. But when the contact breaker opens because of the action of the cam, the current flowing to the base stops, and hence the connection will be cut off between the collector and the emitter. This changes the magnetic field in the primary coil, and because of this, a high voltage is induced in the secondary coil. This results in a high current which flows through the distributor, then to the spark plugs. Thus, the ignition spark is created. This is how the transistorized ignition system works. As the contact breaker is not directly connected with the coil, a high current in the circuit will not affect it. Thus, the system lasts longer. Another advantage of the system is, because of the high voltage taken to the coil by the collector, the magnetic field will be developed in a lesser time and the intensity of the spark will be good. But this system employs the same contact breaker setup which wears over the time as the old systems. Then, the cost of the system is also high. That's all about the transistorized ignition system, guys. We'll meet up again in the next one. Until then, bye.
Okay, so hope you understood well manner the transistorized ignition system with the help of this particular video. So thank you so much for watching this particular video. Thanks a lot.